Hello there and welcome to Nerdy Nog Dog Productions. This is for Chapter 6 Study Guide. What is most important in this chapter is being able to identify the parts needed for measurement for area of a triangle. And on the test, they do word some things interestingly, but again, on a problem like this, we've been doing a good amount of this, we should be able to identify the different parts. So let's kind of review how we would identify. So one question they might ask is that if the height of this here triangle is PW, then where would the base be? So let's first identify PW. So it's saying the height is this here, okay? We see down at the bottom, it does indeed make a right angle, but this here is the height. What we know is that the right angle needs to be made at the baseline, not at the angle, not at the point, at the vertex, at the baseline. So automatically I know that the baseline is going to have to be here. So if my height is PW, that means my base is going to be this line here. Remember, these dotted lines in between, that is sunshine and butterflies, people. So my entire angle would be triangle PRQ, and I'm going to color that in. But the baseline then ends up being QR. So this is the baseline right down here. Okay, now I've used up this vertex, I've used up that vertex, which means the only remaining vertex on my triangle is vertex P, which we call the opposing vertex. Okay, so now we have identified all of our parts. So if the height is PW, the base is going to be line segment QR. Okay. If the height is QX, so now they've changed the height on us. And in the situation where the X happens to be, let's see, I don't have a pen, ready? If the height happens to be QX, that would be this line here. Well, looky there, they actually did put in a right angle. The right angle should happen at my baseline. So this will end up being my base. Opposing vertex is Q, okay? Because on my baseline, this vertex is used and this vertex is used. That becomes my base. So that means that my opposing vertex is vertex Q, okay? We go from the opposing vertex, a straight line down wherever possible, and that creates right angles. So I could go right from that vertex down. It also asks if the height is RY. That would mean that my height is here. So if the height is RY in this case, so I see a right angle there. So that would mean I'm going down from this point down to the ground there, or down to the baseline, even though it's a dotted line, meaning that's sunshine and butterflies, it is extending from this line there. Okay, so PQ would be my baseline, and this would be the opposing vertex. Okay, so a little confusing to cover all of that on one triangle. I hope that is nice and clear, okay? You will be questioned by needing to answer for, when given an example, which is the base of the triangle when the height is. And then again, another question might include, in this triangle, which is the base if the height is, and they will give you the height. So again, you need to be able to identify the height and base when provided with one of them. Okay, very similar to something on the test. Another question that might come up is similar to what was on our chapter review. So let me set up that. Okay, So on our chapter review, questions 15, 16, and 17. If you notice, they give us an angle here, the shaded in angle, okay? So you really do have to use your deductive reasoning skills on this. But they first say ABCD is a rectangle with a perimeter of 48 centimeters. So right off the bat, let's identify our angle. So we've got rectangle ABCD. So they're talking about this rectangle here. And they say the perimeter is 48 centimeters. Well, if you go back to what you know from fourth grade, 48 centimeters and perimeter means the measurements of the box or rectangle in this case, the outside measurements, right? So we're just adding all the lengths and widths together. Let's see if I can center this where it needs to be. Okay, so I've got a rectangle. And I know that the perimeter of this rectangle needs to equal 48 centimeters. Okay. When I look at the rectangle in the book, the only measurement they give me is the 6 centimeters width, okay, from line segment AB. So I can go ahead and label this one side as 6 centimeters, no room for my CM. And so if I'm adding for a perimeter, I know that this width is going to be the same. So now I've got 2 of the measurements out of the 48 total centimeters needed to make up the perimeter. So then my next step, I can kind of say, well, 48 minus 6 plus 6 gives me 12. So at least I know those measurements. So 48 minus 12, and do that math there, leaves me with 36. So that means that my remaining values for the length need to be the total of 36 centimeters. So I can just take that 36 and split it in 2, and that gives me 18 here, 18 here. And to find the perimeter again, I would add up the lengths on all sides. Okay, so altogether that should equal 48 centimeters. So now I've got my perimeter in place. Okay, when we look at number 15 then, it says find the length of rectangle ABCD. Well, now we have to go back again to what we learned in fourth grade for finding area of a rectangle. And you guys have heard me say over and over again, and you should know these formulas by now, but to find the area of a rectangle, we do length times width. So I should have the values enough to find the area of a rectangle. Okay, I can label this as my width, and 18 will be my length. And now I can find the product or the area of this rectangle, right? Perimeter means the measurement of the outside of the rectangle. Area is the space it takes up inside, right? Two-dimensional, 2D. So to solve for that, I would just do 6 times 18. That should give you the area. And then it says, find the area of triangle ACD. So now it's getting a little more complicated. Triangle AC. Oh, let's see. Find the area of triangle ACD. Oh, see, even Miss Nogdave gets stomped. ACD. I read that wrong earlier when I did this on my own. So ACD would give us this space, not just the shaded triangle, which is interesting. Totally not the way I read it earlier. So find the area of triangle ACD. Well, if we're talking about ACD, which would be include this little white bit here, we need to know what the base is. And again, using our deductive skills, we're going to claim that I do know the length from line A all the way to line D. Well, we already said in our perimeter that this length is 18. Okay, so I'm gonna erase my perimeter there. Let's hope I remember. Okay, so now I know that line AD equals 18, okay? I can also say that that is going to be my base. My base is going to be 18, okay? Now, how do I measure height of a triangle? If I'm claiming that this entire bottom makes up my base, then I have vertex A and vertex D as part of my base. I go to the opposing vertex, the only one remaining would be vertex C. Okay? Now, how do I find height on that? Well, here's my opposing vertex. I start at the point and I try and make a straight line down. And this works out perfectly because I would just stay on the line there. I would go down to point D and it does make a 90-degree right angle. So do I know the length there? Yeah, look, it would be the same as this length here, which would be a value of 6. So now I can say that my height is 6 centimeters. And then the last question on there was find the area of the shaded triangle ACE. Oh no, so now it's doing just the shaded. Okay, so before we move on, let's go back to 16. Can we solve for that? Why, yes we can, Miss Nogdave, because we now have the base and height. We also know that the formula for area of a triangle equals the base times height divided by 2. Therefore, I can say 18 times 6 and find that product and then divide that by 2, and that would give me the area to meet here. Now the same would go for the shaded triangle when you're solving ACE. What are you going to claim as your base? How are you going to account for this white space that isn't used? Well, let me give you that hint. If you notice, they give you a little notch right there. So they're indicating that there are 2 segments here. And when we look here, we can kind of say, well, that is a matter of 4 remaining segments. So a total of 6 segments. And if we know the value of that length is 18, and we divide 18 by 6, that would mean that each little tidbit has a value of 3. Well, look, there's 2 or 3 plus 3. So we could solve for this saying that this value of line AD is 18 centimeters minus 6, and know that from line segment AE we would have a value of 12. So that becomes our base. We go back, we still use the opposing vertex of C. Do we know the height? Well, yeah, because we're not going to use the length between CE. We're going to use the most direct route from that point down to the ground or down to the base, even if that is not truly there, and that is just sunshine and butterflies, people. Okay, so I hope that was helpful and that makes some sense. Thank you. Study up.